Hey guys, Carnus here. So, if you've watched my last video on actually building the controller for the cooling system, today we're going to get the actual system up and coded. So I've got it wired up, it's sitting up there. So let's just remind ourselves what we've got. So you've seen this diagram before, I'm sure. Pump, water out, water in. Right, so what we've got, let's just get a different color, is a flow sensor here connected to pin D2. Temperature out from the laser cutter. So the laser cutter's over here, flowing water that way and that way. That's connected to D10. And a temperature into the laser cutter, that's D8. So what we want to do is basically start measuring the flow and the two temperatures. Now it's wired up. I haven't turned the pump on, so there's no flow at the moment. But let's just see if we can't get the temperature readings going. And I suspect at the moment the water's probably somewhere around about 20 degrees C, something like that. So let's flick to the IDE and start working. So here's the IDE. You're all familiar with this, hopefully by now, the Arduino IDE. So let's just begin where we should begin. So serial.begin 9600. And let's just serial.println system. Oops. Minute. I'm switching on the wrong keyboard for some reason. Thank you, Windows. I want to use. Yeah, it's better. So this is the coolant controller. Up. So let's just save, upload that, and monitor it. What do you mean select board? There you go. I've got a board. Thank you. Okay. Don't know why they don't do it. But let's just put here serial controller loop. And we should just get this loop, 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 loop. Upload it. COM7. Why don't you want to monitor it? Weird. No, the other. Just got a couple of other open, making sure it's not. No, the others are not connected. Select board and port. Tools. Board. No. Tools. Port. What do you mean unknown board? Okay. Let's try again. Tools. Serial monitor. There we go. Weird. Just initialized itself along. So there you go. Loop, 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 loop. So we're flying through looping. Cool. So first off, let's get the library installed. There we go. So first off, if you remember, if you watched the tutorial, include, oh yeah, if you watch the tutorial, you'll see also there I can't type. DS18B20.8, which is the device we're using, and the DS18B20. So let's put temperature in equals temperature in. Now, what did I say it was? So temperature into the system is D8. And temperature out of the pin is, no, let's just go 10 and 8. So let's just get them up and running. So let's just copy and paste because I can't seem to type today. Temperature in dot select next. So basically what this is doing is just saying I want to use those ones, and then let's set the resolution, because realistically we're not worried about resolution. I'll just copy that from somewhere else. Res 9-bit. So what we're saying is we only want 9-bit. It's faster. If we do full 12-bit, it just takes longer. And then every time around the loop, we'll just go serial.print print. We'll go input dot get temperature in C. Oops. It's temperature dot out. So we'll go in, out, and then we'll just do, what do you reckon? Sleep for a few seconds. Yeah, probably not a bad idea actually. Delay. Oh, where's my pointer gone? Right. Delay let's just do every 5 seconds. And then just to make sure we know what's happening on serial.print in so that's C space out, and then serial.print line C. Just because I'm pedantic, right? Verify that. Did you mean DS? I did mean. Okay, I can't spell DS. Verify that. Done compiling. Let's upload. Ding. Serial monitor. Let's clear that. Clear. 1, 5. Let's speed that up actually. Is it 1, 5, 1, 5, 200? We don't need to be that slow. Right, upload. Serial monitor. We want serial monitor. Serial monitor. Let's run that, please. Clear. There you go. In 19 degrees, out 22. And I think the input, because that's lower actually in the tank, this is at the top of the tank. So that looks reasonable at the moment. So actually that's in the water, that's out of the water, because at the moment the sensor is suspended, will be suspended in the water flow coming out. So yeah, so 23 degrees in the shed at the moment, which is about right. So now we want to start picking up the flow. Now the flow, if you remember last time, actually let's just put a module here and go, not a module, sorry. You need a method here, which is, so remember, we're doing, watch the tutorial, we need to do a, what's the name? Interrupt. God, brain is not working at the moment. Too hot. You enter 16, type count equals 0. Oops, 0. So what we've got here is this pulse detected function will get called whenever the flow meter detects a pulse, and that'll increment the count, and then we process the count to say, how many pulses we've had in the last second, and then do the maths. Watch a tutorial, which I'll make sure I've got a link somewhere. You should be able to find it on my channel on how this works. So this is the last timestamp. So last equals millis. So that is, what's the name? Now, basically, in milliseconds since the controller came up, the bit nano came up. And then if we want to attach an interrupt, what interrupt is it? Well, it's 0. We want to do pulse detected, and then we want to say we want it on falling edge. Falling, rising, either. Neither of them really makes a difference, but falling makes sense to me. So now we do that. And now what we need to do is I'm going to cheat at this point and make a function called void calculate flow and copy and paste the function that we wrote previously. Copy, paste. So this code here, I'll just get rid of the comments for the moment, is the same code which is in the tutorial. So this will return new int 16 flow rate. And I won't return a float. What am I doing? And let's just return the flow. Now, that number will be wrong. That number there, the 6.6, is the calculated conversion rate. The one I used in the tutorial, the flow meter I used in the tutorial, I think it had a rate of 26. I think the one I'm using has got a completely different rate. But what we're going to do is we'll calibrate this, because I'm not sure when they give you a correction factor, as in what you divide the numbers by, I'm not sure at what flow rate that's valid. It may be the top of the range, maybe the bottom of the range, maybe mid-range. So I want to calibrate it so when it's working at about where I want it to work, it's got the right value. So this will now calculate the flow for us. So what we'd say, well, input temperature, output temperature, change that to print, and then we'll do flow rate, serial dot print line. Let's just print line, was it liters per minute? And then we'll do serial dot print calculate flow. That's how I spelled it. I shall check in a second. Yep, calculate flow. Yep. Right, let's just verify that. What did I get wrong? Yeah, not unit. Int. Verify that. Bit of comma for delay. Oh, sorry, semicolon. Too much Python recently. Right, upload. So that's running. Hopefully, serial monitor. Let's have a look. Not a number. Right. So what we need to fix the code to actually not report a nan. Oops. So why is it returning not a number? Because that's 0 divided by a valid number. Weird. Flow equals frequency, so that should be positive. Right. So something's wrong here. So we'll just start dumping some. We'll dump the frequency out. Then we'll dump the flow out. We'll dump the period out. Let's see what's going on. I'm doing one calculation wrong somewhere. Nan. Oh. So what's the first one? A 0 and 3 nans. 0, nan. I need to be a bit more clever here. Serial.print line. Nope. Period. Frequency. And we'll do flow. And then we'll just, for the moment, comment out all that. And let's just see what we get. because we know the code works because we had it working previously. So I've just clear it, what we get. 2, 3, 0, frequency nan. Why is that? Why is it period 0? Now equals milli. Last equals milli. Oh. Yeah, that'll do it. Spot the obvious mistake. My tutorial's wrong. How did that pass? Because I'm sure I've run that tutorial. I have to fix that now. So now equals millis. I don't want to do that until there. Because what I was doing is I was basically making last now, then now minus now. That should fix it. Upload. If so, I have to go back and check my code. That's embarrassing. 1, 2, 3, 4, 502. That's fine. 0, 0, 0, 0. Yep, that's a lot better. So now I've fixed my obvious faux pas. I shall just fix the tutorial code, which is embarrassing, but never mind. That's what happens when you don't have tests. Oops, nope. Do that again. Right, let's upload that. And that should now have us going 19 degrees, 22 degrees with a flow rate of 0. Clear that. How are we going? Get rid of that one, but in, out, flow. Some spaces there just because I'm pedantic. But that looks reasonable to me. In, out, flow rate. So now, I verify that, get that running again. I shall turn on the flow, turn on the pump. So you might have a bit of a hum in the background. I apologize. Let's clear that. And let's actually dump it down to 2. Every 2 seconds we'll take a reading. So, let's just see if that gets picked up on the mic. Nope, doesn't appear to be picked up, so that's good. Okay, so takes a few seconds to start flowing, but 5.7 liters per minute. I know that's wrong. Wow. But at least it's picking it up, and we should notice that this temperature should start dropping, so the output should start dropping because it should now have the water flowing over it, and it looks like it is. So that's good. 21, come on, that should drop down to B. Okay, interesting, that's gone up slightly, but not a problem. So these two should become the same. So input output should become the same. And I know the flow is not 7.6 liters per minute. The flow is closer to 1.5. Well, that's what it was last time I measured it. So 7.62, 7.71. Okay, so that's looking reasonable, given the fact that it's actually flowing around and cooling the whole laser tube down and everything else. So I'd suspect a slight discrepancy there. Right, so just pause for a moment. So be 1 moment, please, while I go measure how much flow I'm getting, and I shall come back with the numbers in a second. Right, welcome back. Okay, so I've run 500 mils. So these are the times for 500 mils in seconds. So, yeah, roughly looks pretty good, to be honest. 20 seconds each thing. So 20.03 plus 20.46, 20.32, 19.96, 20.21 plus 20.16 plus 20.48, 141 seconds, 0.62, 1, 2, 3, 4, 5, 6, 7. This divided by 7 gives us an average of 20.23 seconds per 500 mil. So if we want that in liters per minute, we basically say, well, how many times does that go into a minute? Multiply that by 500. So 60 divided by 20.23 gives us 2.96 lots of 500 mils. So that gives us a total of 1.482 liters per minute. So let's just call that 1.5. And I'm trying to get about 1.5. So I'm quite happy with that. Now, the problem is at the moment, if we look at this, we're getting 7.72. So the flow we're getting is 7.72. Frequency, we don't know. So let's just comment out this lot. Actually, it's not comment out that lot. Just call calculate flow. So we just get it called, and let's just output the frequency because that's what we're interested in. Serial.println frequency. So how many pulses per second are we counting at the moment? Because I haven't turned the pump off, so this flow rate stabilized to give us a currently. So we're getting infinite. There we go. So clear output. There you go. 50.97, 51, 50.97, 50.5, 50.97. So 1, 2. Let's just get 1, 2, 3, 4, 5, 6. We took 7 samples, so let's toggle auto scroll. 1, 2, 3, 4, 5, 6, 7. Yeah, actually, to be honest, I'm just tempted to say let's just go for 51. 51 and 1.5 liters. So if we're getting 51, what do we have to divide it by to get 1.5? So, well, we know the flow rate, 1.5. We don't know that number, the 6.6. So the way I always was taught, you have a triangle. You have A, B, C. So if you know A, if you want to know A and you're B and C, you cover A and you're B times C. If you want to know what B is, you cover A times C. It's just the way one of the ways I was taught years ago. So we know the flow rate, and we want the frequency divided by we'll call it the adjuster. Well, flow rate equals frequency over adjuster. Okay, so if we put those into flow, frequency, adjuster, there's the triangle. We know that. We know that. We need to know this. So you cover that up. It's frequency divided by flow rate, which gives us 51 divided by 1.5, gives us an adjustment rate of 34. I'm just checking to see what is actually printed on the device. Here it is, what we got. And the device saying 23. Now, I was reading somewhere else, the adjustment factor was 36. So I'm not sure which one's right or wrong, but we know 34 will give us what we need. So let's go back to the workbench and change that from 6.6 to 34. No, did I say 34? 51 divided by 1.5. Yes, that's right. So let's upload that. And we should start seeing the exact same thing because I haven't done that. Stop being a muppet. Comment that out. Get rid of that. And let's upload that. Dum-de-dum-dum. Clear that. There we go. In, out, flow rate. That's what I want. So that currently is working, but not quite what we need, because what I actually want to be able to do is start talking to it via serial. So if you remember, if you go back and watch my tutorial on serial comms, the whole point of that tutorial was the fact that I now start wanting to call this remotely and be able to say, right, give me the reading, give me the reading, give me the reading. And the system will then calculate the readings as and when. So this needs a bit of refactoring. So first off, that's fine. Calculate the flow will give us a float. So then let's do, so what is this returning? It returns a float as well. So we do float, calculate input temp, float, calculate output temp. And let's just move these ones out of here. Now you don't have to do this. This is just me making my life a bit easier to understand later on. So we now have calculate input, calculate output, and calculate flow. Let's get rid of this. So we only want to do this when we actually want to send output. So if you remember what we were saying before, well, not before, but if you go back and look at our serial comms many moons ago, one of the other Arduino tutorials, we want to leave that there. It's fine. We want serial. We don't want this, because I don't want to output anything unless I ask for it. So let's just do some copy and paste from the code we wrote before. So first off, let's define a buffer for the serial comms. And let's buffer size. So this is a buffer to hold the data, where we currently are in the data, and a couple of flags to say how we started or finished. I'm not going to explain how the serial stuff works. Please go have a look at the tutorial. I've explained it all there, and hopefully it all makes sense. We then have another method, which I'm just going to copy and paste. A couple more methods coming in. So we come down here to the loop. So in this one here, we go through, pull the data off the serial buffer, process it, and try and see if we've actually got a command. If so, we then process that command, and then the loop basically becomes this. So this is just literally copy and pasted from the tutorial. What the commands we want to say is here, well, actually, this is a coolant controller. So that's what we want to do. If we get the ID command, is we actually want to tell the other end, hey, we're the coolant monitor, and if we do reading, this is where we do. I think it's called reading. Hang on a minute, please let me just check what I send it. Send an ID request. What's the send command? Reading. Yep. I'm just looking at the monitor stuff, which I've got another tutorial discussing at some stage. If we get reading, we want to return back the reading from the system. Now, that needs to be in a fairly easy to understand way of being read. So what we do for that is we send back a three basically we return three numbers. And what we want to do is format those in a way that makes sense so we can actually then process it up. So what we're going to do is quite simply, if you ask me for a reading, I'm going to send back my start character because I always use the start. We'll send back end character. So that is the start and stop character as the angle brackets. And serial.print, print string dot, I think it's a printf we have, print formatted string. So we always want to have now send. Temperatures are always 2 dot something. So it's always 2 characters dot 1 because we're never going to go negative, so don't have to worry about the plus minus. And we're not going to go above 100 degrees C. If we hit 100 degrees C, we're in big trouble. So this is calculate. And what do I call it? Calculate temperature in. Calculate input temp. Then what we output then is a comma. Actually, we don't need to format it because I separate by comma. So I'm just changing my mind. I'm allowed to do that because I remember now I used to have it hard formatted and then I fixed it to actually just accept numbers separated by commas. And then this one is calculate flow. So that's it. That's as complicated as we're going to get. So let's upload that. Oh, what have I done wrong? Not too many brackets. Fair enough. Verify it. Yep. Send it up. Dum. Thank you very much. Clear that. So nothing's going to happen if we send it ID. There you go. It comes back where the coolant device. So I'll take a reading, please. There you go. 20.37 degrees in, 21 degrees out, and 1.51 liters per minute. So if we do reading again, boom, boom. There we go. This looks suspiciously the same. No, there you go. It is changing. Resolution isn't great. So wait again. Reading. There we go. Send another ID. And then if we send it Bob, it'll just go, no, ignore it. So that is it. We have now got a working controller for the coolant system that measures flow, temperatures and flow. So this code will be up at some stage on a repo. I'll make sure I share some links around. I'll fix my serial comms, no, not serial comms, the flow sensor code and push that one up as well. But yeah, hope you found that interesting. We now have a working controller that I can now talk to for getting the information about the coolant. So stay tuned. There will be a similar one shortly for the icing system, which has the bypass controller on it as well, or bypass relay. But hope you found that interesting. Like and subscribe, and I'll catch you guys later. Bye.